Okay, question 16, nearly finished. Okay, nearly finished. When you get to this point in the exam, don't lose momentum, don't lose focus. Try and practice. It's good doing little snippets, doing questions at a time, but now and again, like training, if you're doing marathon running or if you're training for a marathon, don't just always run marathons, but don't just always do 100 meters. Okay, do mix it up. So every day doing a little bit of maths is really good, but now and again, try and do like a full paper just to see how it feels. Trying to keep that concentration up because it's easy just to lose concentration, lose focus, and you start making silly mistakes. And then as the questions get harder, you can make stupid mistakes and lose marks. All right. So, but yeah, we're nearly there. So we should just keep the focus up if you're in the exam, right? Okay, so I'm just going to quickly draw or try and draw um, our axes. Okay, so let's call that the x-axis, obviously, and the y-axis. Okay, so we're to sketch the graph, and we're going to show the intersection with the x and y-axis and the turning point. Okay, so intersection with the x-axis. My pen work is getting better, but it's still not quite perfect. So intersection with the x-axis, which make it an arrow actually. How do we know where it crosses the x-axis? Well, when the graph crosses the x-axis, okay, y is equal to 0, isn't it? So along this plane, y is always equal to 0. Okay, so if you take this equation, you say x minus 6 and x plus 4 equals 0. So whenever this result gives you 0, you know you're going to have cut the x-axis. So how do we get this equal to 0? Well, if one of these brackets is 0, just one of them, so if x minus 6 becomes 0, the whole thing becomes 0. And likewise, if x plus 4 becomes 0, then this times 0 would give us 0. Okay, so basically what you're saying is x minus 6 equals 0 and x plus 4 equals 0. Okay, now you can just look at that and just say, well, x is obviously equal to 6 and x is equal to minus 4. That's nice and straightforward. If you want to think about what we did algebraically, well, we were saying, well, if x minus 6 is equal to 0, I've got a minus 6 on this side. How do I move it over that side? Well, I'll do the opposite. Add 6 to both sides, so it becomes 6, okay? And like I said before, what we're doing here is we're actually saying, let's add 6 to this side, and let's add 6 to this side to balance it out. So minus 6 and plus 6 disappears. We're left with plus 6 on that side. So that's what we're doing when we move things over, okay? So x minus 6 is 0, so therefore x is 6. X plus 4 is 0, so x is minus 4. So on here you could mark up, you could say, well, I'll call that 6, I'll call that minus 4. So right away we know that's us got one thing, so we know it's cutting the x-axis. Cool. The other thing's the shape of it, okay? Is it going to curve this way, or is it going to curve that way? So is it a positive parabola or a negative parabola? So this would be a minus x squared, okay? And this would be a plus x squared. Okay. So if we took this formula, x minus 6 and x plus 4, well, x and x is going to give us x squared. That'll give us minus 6x, 4x, and minus 24. So we'd actually end up with x squared minus 2x minus 24. Okay, so it's an x squared. So we don't need to know the rest of it actually. They might have given us that to start off with actually and made us factorise, but they helped us. But yeah, we know it's a positive, okay? So I know the shape of it is going to come down like this. It's going to end up somewhere, okay? But where's it going to end up? So that is going to be the turning point. Now the turning point is always right in between these two roots, okay? So I've got a root of 6 and a root of minus 4, so the distance between them is 10, okay? That distance there is 10. So it's 4 here and 6 here, 10. So it means in the middle is obviously going to be 5, okay? 5 from each of these. So I can do 6 minus 5, which would be 1, or I could do minus 4 plus 5, which would be 1, okay? That's where the turning point is going to be. It's going to be on the 1, okay? But how far down does it go? Okay, so what's the y coordinate? Well, let's use our equation. So we know y is going to be equal to 1 minus 6 times 1 plus 4. Okay, so I've just taken this equation here and substituted in for x is 1. So that's going to give us minus 5 times 5. So it's going to be 25. Okay, so the coordinate of the turning point, sorry, minus 25. So the coordinate of the turning point is going to be 1 minus 25. Okay, so all the way down here, so minus 25. It's not terrible. Well, it looks like rubbish now, but it was actually quite good. I'll just take off those last two little bits. They kind of ruined it, didn't they? Shaky hands. So yeah, that's our turning point. 1 minus 25, and we've got our two roots. So we've got the turning point, we've got the roots. The last bit is where it cuts the y-axis. Now we can look at that and say, well, it's definitely going to be higher than minus 25, and not by much, because it's just next to the turning point is right next to the axis, isn't it? But how do we find that out? Well, I'll rub this out to give us some space. It crosses the y-axis when x is equal to 0, doesn't it? So this plane here, x is always equal to 0. So if we just put 0 into this equation, we should get it. So y is equal to 0 minus 6 multiplied by 0 plus 4. So minus 6 times 4 equals minus 24. Now I'm looking at that thinking, yeah, that makes sense. That absolutely makes sense. Okay, so it's in there, minus 24. Simple. All right. Now, unsurprisingly, you get a mark for your two turning points. Okay, you get a mark. Sorry, your two roots. You get a mark for your turning point, and you get a mark for the y-intercept. Okay. Now, just to be really good, I think I would put. I mean, I'd mark it up quite similar to this, but I might just write the coordinates down, just to be precise as well. Okay. You don't have to do that as long as it's marked up well. That's fine. The only coordinate you really need to show is this turning point, the 1 minus 25. So maybe showing it like this wouldn't be enough. You may just have to write the coordinate next to it. But here you could obviously, again, I would just write the coordinate, so for the x, I'd be putting 6, 0, minus 4, 0. And then for this, I'd say 0 minus 24. Okay, just to be really exact. Okay, so that was sketching the graph. Nice and straightforward. Volume. Okay, so a square base pyramid is shown below. 6 and 6, so we don't need to worry about that. That's already shown. The volume is 138, so I'll just write up here volume is 138. That's good. And we're calculating the height of the pyramid. Okay, so what's the volume of the pyramid? Okay, well, it's given in your formula sheet at the front. Okay, so it's going to be volume is equal to a third AH. I should really know that off the top of my head. That's shocking that I didn't. I just wanted to double check. A third AH. So it's actually really similar to the volume of a cone, which is a third pi r squared h. So in this case, A is just the base of the pyramid. If it's a cone, that would be a circle. That's why that would be pi r squared. The only volume I think that the sheet doesn't give you is a cylinder, but actually it does in a way, because the volume of a cone, it tells you is a third pi r squared h. Now the volume of a cylinder is pi r squared h. So as long as you remember that the volume of a cylinder is the same as a cone but without the third, then you've actually got that as well. So there's not a volume you're not really given, so that's quite good. So yep, so we know the equation, they've given us it, and we've got all these variables, so let's see if we can substitute it in. Okay, so they said the volume is 138, third times our area. Now area is 6 times 6, which is 36. It's not 12, some people might accidentally put 12, okay? Times the height, which we're trying to find. So let's simplify that, shall we, okay? And again, you would show all your work, and I'm not going to show all of it just because I've got space. I can just scroll down. Sorry, scroll down. Yeah, plenty of space. So 36 divided by 3. I think I would do that. So 138 is equal to 12h, because 1/3 times 36 is the same as 1/3 times 36 divided by 1. So that's just 36 divided by 3, which is the same as 36 divided by 3. Okay, so 138 is 12h. Then, working line, I'm doing 12 times h. If I want to move the 12 over here, I'm going to divide by 12. Okay, do the opposite. Now, like I said before, what's happening here is I'm dividing both sides by 12. Okay, so because I divide both sides by 12, it cancels it on this side, and it moves it over there. Okay, so 138 divided by 12 is equal to h. Okay. Now, looking at that, it's probably not going to be a perfect number, so I'm going to suggest you do long division. Now, folks don't seem to like long division, but it's actually very, very simple. Alright, so 12 into 1 doesn't go, carry the 1. 12 into 13 does go, that's 1, carry the 1. 12 into 18 does go, that's 1, carry the 6. Now we'll do 0.000, carrying the 6. 12 into 60 is 5, don't forget our point, okay? 11.5. Okay, so let's just check the marking scheme. So we're going to mark for starting the substitution, you're going to mark for finishing it, and then you're going to mark for calculating the height. So you're going to mark for this. At this point, you've probably got a mark. You're kind of getting a mark for this side of the equation, then a mark for that side, effectively. I thought there might be a mark more for rearranging, but it just says start substitution and then complete substitution. So it's kind of like a mark for this and then a mark for that. Okay. So yeah, 3 marks for that one.